All right. Towards the end of this section, I want to talk about some of the special cases of absolute value equations and inequalities that you may come across. Now let's go ahead and take a look at what these special cases might be. Now when you have a typical absolute value equation or an inequality that involves a negative constant or zero alone on one side, you have to consider these two properties. Now so far we have talked about where on the one side you had a positive k, but what happens if that positive, that k is not positive, it's a negative or it equals 0. So this is what you will do in situations of that form. Let's say if you have a negative number. Now remember that the absolute value of an expression can never be negative, because again remember we talked about it as being the distance from 0, and distances are never negative. So that is why we say that the absolute value of an expression can never be negative. Your absolute value of any real number a must always be either 0 or greater than 0. Now let's see what happens if it is 0. When is a absolute value of an expression will be 0? Only when the expression itself is equal to 0. Okay, so you have to keep these two properties in mind when you're dealing with special cases where your k is a negative number or your k is 0. So let's just look at some examples here for our special cases, and let's see what we can come up with. Now, we're looking at our first example here. We have an absolute value equation. Absolute value of 13w plus 1 equals negative 3. Now, if you remember, we just said that the absolute value can never be a negative number. You cannot have the distance of this expression from 0 be a negative 3. So that tells us that this cannot be solved. This equation has no solutions, and your solution set will be an empty set. To represent an empty set, again remember we use the circle with the line across it. So since this expression has no solution, your solution set will be an empty set. What happens, let's say, if you have an absolute value equation that equals 0? That was our second property that we talked about. We said this expression can have a distance of 0 only if the expression itself is equal to 0. So in this case, when you're solving it, what you will do is take your expression, absolute value of 6r minus 2 equals 0. To solve that, we will just take the expression 6r minus 2 and set it equal to 0. Okay? And then you would just solve this for the variable like you would any other equation. So we have 6r minus 2 equals 0. Move your 2 over to the other side. Okay? And that will give you 6r equals 2. Divide everything by 6, and you end up with r equals 1/3. Right, now let's go ahead and check and see when r equals 1/3, then will our expression equal 0 here? So to check our answer, we will take 6, substitute our r with 1/3 minus 2 equals 0. And 6 times 1/3 will of course give you 6/3. You can reduce 6/3 down to a 2. Okay, so 6/3 and then 6/3 reduces down to a 2, and you end up with 2 minus 2, which of course is 0. And as we know, absolute value of 0 is going to be a 0. And we end up with a true statement. So that tells us that the solution set for this absolute value problem here will be just the one number 1/3. Okay. All right, let's look at a couple more special cases here involving inequalities of absolute values. So let's say we have something of this form here. You have the absolute value of x plus 9 greater than -3. Now try and understand the concept here. We are saying the absolute value of this expression has to be greater than -3. Now we know the absolute value cannot equal a negative number. It has to equal either 0 or it has to be a positive number. So no matter what value of x we choose, you can try plugging in just a 0 there. 0 plus 9 will give you 9. Absolute value of 9 will be greater than -3. Try plugging in, let's see if we can, you have, absolute value of x plus 9. If we use x equals 0, you end up with 0 plus 9, which is absolute value of 9. And we know absolute value of 9 will be a positive 9. And of course, positive 9 is greater than -3. So no matter what value of x you choose, your absolute value is always going to be greater than -3. And we can conclude here that absolute value of x plus 9 greater than -3 is going to be true for all real numbers. You can plug in any real number for x and you will always have a value greater than -3 for your absolute value. So you really don't have to solve this expression. All you really need to do is identify what sort of a problem this is, and you can see that your solution set will be any real number, -infinity to infinity, all numbers in your real numbers. Let's look at another scenario. Let's say we have an example of this form. You have absolute value of 10z plus 7 plus 3 less than -1. Less than 1. So you can see that this is a positive number, right? So this absolute value, of course, is good to go. But what happens when you rewrite this problem? Now remember, you want to get the expression by itself. You don't want that extra 3 there. So the first thing we will do is move that 3 over to the other side, and that will give you absolute value of 10z plus 7 less than 1 minus 3 will give you a -2. Now, think about it in these terms. In our first example here, we said that if the absolute value was greater than -3, you had a solution set of all real numbers. But here, we are saying that the absolute value of this expression is less than -2. Now, we know whatever value of z we choose, the absolute value has to be either 0 or greater than 0. No absolute value is going to be less than a negative number. They're always going to be greater than the negative number, and therefore we will say for this example that the absolute value will not be less than -2 for any number. So your solution set for this example is going to be an empty set, because there is no value for z which will give you an absolute value of less than -2, and therefore you end up with a solution set of an empty set. All right, and that concludes our discussion on chapter 9.